Hello, this is Nitin Dahad with E Times. Welcome to the latest edition of Silicon Grapevine. My guest who's come back to this series is Sammy Cheung, who's the CEO and founder of Efinix. Sammy, hello, how are you?
How are you, Nitin? I'm doing very well
Okay.
and very excited in the meta world.
Yes. So we're actually recording this in Europe. Sammy's made a visit to one of the key trade shows here in Europe called Embedded World. But let's talk a little bit about things that have changed over the last few years since we last spoke. Some of the opportunities and maybe just some of the learnings from all of what you've done in the last few years and since you founded as well. And we touched a little bit of that in the last episode, but I think it'd be nice just as a reminder for people.
Sure, I mean that's great. I think time flies, but only a few years. There's many changes.
Yeah.
I think there are two major changes since last we talked. As promised, we roll out our titanium FPGA family,
Yeah.
which is one of the best FPGA in the world right now, and it's being empowered by our disruptive technology that is now become one of the major player in machine visions and all sort of near sensor edge AI processing. On the other hand, we also see the rising of the edge AI applications around the world. I mean, we have heard quite a bit, whether it is in a machine vision in a factory, I mean, autonomous machine, as well as autonomous car like LiDAR, radar. And as a matter of fact, because of its unique differentiation in titanium, it's got designed in many of those applications in the last few years. And then finally, we see the very quick growth starting last year. I can share a little bit from 24 to 25. Our growth is over 100%.
Okay.
And then we also seeing that as FPGA being more than 50% of our new designs are all in edge AI and edge AI related systems. And we see the next few years, we expect continue to have really high growth.
Well, that's actually interesting because if you think about the whole euphoria right now in the industries around edge AI, physical AI, humanoid robots, but what you're saying, it's validated by your figures as well in terms of the proportion of the business being edge AI.
Oh, absolutely. I think that two portions of it. I mean, first of all, I mean, the whole AI proposition is super excited, right? Of course, it starts with all the excitement in the data center, both from the actual agentic AI and many applications that require GPUs and a lot of great company building data center infrastructure. However, this booming create a lot of AI computation capacity.
Yes.
And now they're looking for creative innovation in the edge to generate all this data, be able to process in the data center.
Yeah.
And our technology actually is rising at the perfect timing. Guess what, right? At the edge is very different from data center. I mean, it requires a few fundamental things that, of course, at the edge, it requires mostly real-time processing.
Yes.
A lot of like tight integration so that it can get the form factor of whatever devices that build at the edge to be small. Has to be low power. And at the same time, because of the integration, it requires a high performance.
Yes. Yeah.
And guess what? With all the inference, with all the algorithms, with all the different model, edge is a very fragmented world. So a lot of innovators need to test the market, build various devices, different model, different environment.
Yeah.
So what that means, they need programmability.
Yeah.
So combining all these factors, it's turned out that our innovation in Efinix, our fabric, which turns out perfectly fit in the requirements. And it is not like Efinix device can do everything. Because of these disruptions in terms of be able to provide programmability near the sensor, near the data generations, we actually can help integrating many things, many devices. We talked about it back in a few years back.
Yes.
Now become reality that we work really well with different type of sensors, whether it's vision sensors, whether it's thermal sensors or mix sensing. We have technology that integrate many sensors. We have clients asking about not integrating one, two, but try to integrate a bunch of sensors and a capability built in our devices together with a high density fabric, totally fulfill those requirements. And on top of it, just to recap, FPGA company is not just one chip, and our efficiency of the technology allow us to build. Actually, we have now, within the last 5 years, we built over 500 ordering codes, and
500?
500 ordering codes. That means customer can have different choices to design their systems, whether it's a low density device to a much higher density device like our TI 375, 375 K logic element, and we provide different I/O interface, like different sensor interface, memory interface, and also high-speed transceiver, which we delivered in the last couple years.
Yeah.
And now it's primed to grow. The most exciting part is we feel like this is just a beginning.
It feels like it. Yeah.
But another excitement that we have is not about, yes, it's a business, we want to grow, but we often see our customer are so happy. Now they finding a new platform, a new paradigm of FPGA platform that allow them to do a lot more innovations. And I have many incidents here that our customer come surprise me, that they come to me and say, thank you so much for delivering this new type of technology. So.
Right. I mean, one of the things you said just now is about the fragmentation of that market, the edge AI market.
Sure.
Is there a sweet spot for titanium and for Efinix in a certain range of types of applications? I think you talked about vision, image sensing.
Absolutely.
But there's levels of complexity, I guess.
Sure. I think we can make it simple, break it into two segments.
Yeah.
Like for example, let's talk about logic element density range, right? I mean, we usually between 60,000 to about 180,000 is really good in near sensor processing, which I mentioned. A big part is some of these sensors just cannot tolerate heat. So if you are too hot, too much power consumptions, the heat generated will distort the sensor quality and the image.
Yeah.
Having said that, they all want programmability, and actually Efinix titanium is perfectly good at that. When you have high density, actually we have, other than the straight up sensing, now we have new 3D sensing, aero sensing, and also auto types that require integration. Because going back, it doesn't matter is it in a car, in a drone, or in a robotic humanoid right now. They need your visual, right? Whether it's thermal, visions, or LiDAR radar, they all need to process it. So we are primed for that. But then when we start moving up the curve, let's say between 200,000 to like 400,000 lookup elements, now we start to get to something even more exciting. It's like we have PCIe, Gen 4 PCIe offering. That means we can do the PCIe plugin embedded for do AI accelerations. And this year is suddenly we have a lot of customer doing all sorts of things. They're building platform. I mean, basically it's very classic. I mean, you can use FPGA accelerating, offload the processor workload to get much more energy efficient accelerations, and also be able to handle undeterministic workload. So those are the things that become popular. But one little things, I mean, we haven't really rolled it out, only our clients is doing it. Is our TI 375. Used to be a pretty big device in the old day in the FPGA. Now it's super small. So we can deploy it in that density on a M.2 form factor PCIe card, which is super small. I saw a few of the clients that deploy it. It is going to be very exciting because this is the first time that big FPGA with that lower power can be a so small form factor PCIe card.
Yeah.
So what that means, it can translate to what I call high volume PCIe acceleration in different form factor. Yeah. So
It's one of the things you said is about energy, and everybody's talking about energy now in terms of efficiency and then the cost, and so I think there's something again where you hit that point, don't you?
oh yeah, the FPGA being used for some people call it hardware accelerations,
Yeah.
but often it's really compute offload.
Yeah.
So when you change from a sequential processing in a processor to massive parallel processing, that will actually usually the factor can be 10 to 100x in saving the power.
Right.
But of course, in a lot of SoC right now, there's hardened functions, which is a lot more efficient. Unfortunately, the hardened functions cannot is deterministic, right? When you're in the world, especially in the edge AI world, there's a lot of things that you want to be upgradable. So programmability is there. So with the specification that we have, I mean, if you talk about the total sort of saving, not just lower power, but also saving the chassis for thermal enhancement, we save a lot in terms of area, size, but again, it's a much better efficient platform to offload compute, right? We didn't invent it this like for so many years. However, this is the first time when we start seeing this kind of new technology.
Okay.
And more exciting is this. Today, our titanium is on the 16 nanometer.
Okay.
And imagine the last 4 or 5 years, we have technology and methodology that can roll out that many devices. It's not surprising that we will have even higher density device being built in a what I call a more advanced silicon processor.
Correct.
At that time, maybe in a couple of years, you will still seeing some even newer, better computation capable FPGAs, not only serving at like near sensor machine vision, or can be served in a very small form factor chassis, be able to do compute offload.
Well, that's amazing about the semiconductor industries over the years and through your career would be like driving down size and cost, but improving functionality and performance.
Although that's classic for FPGA. I mean, I myself work in the FPGA industry over what 30 years.
Yeah.
Yeah, so it's exciting that we now it is a big part leading the new paradigm, and it's just a straight up role. I mean, but one important thing we do have a breakthrough is like building chip is expensive, finding killer apps is difficult.
Yeah.
But having an efficient technology and efficient methodology, we are totally confident that we have the technical portion that can build even bigger devices. Bigger means it's not big in size, it's higher density.
Higher density.
Higher density.
Yeah.
And even lower the power even further by going to the more advanced processes.
Yeah.
While doing that, our cost of development will be in a fraction compared to traditional technology.
Right.
So what does that mean in business? That means we have a much better return on investment compared to the rest of the industries.
Right. Let's talk a little bit about Efinix and the growth. I think last time we did an interview on video, it was at your 10th anniversary.
Oh yeah.
So like you've had quite a journey, and like between the 10th anniversary and now, just give me some of your, we talked about it at your that time, but give me your feelings about like what it was when it started and how do you feel now about the whole business?
That's a great question.
But both about the company, but also about the industry.
Yes. At the 10th anniversary, the AI thing is just beginning. It wasn't really taught that much, right? But we already talked about how our technology is so small can be a big part of the future intelligence integration and intelligence solutions. At that time, we only have, it's the first time we have a first generation of device, which we call Trion. It's more a fundamental device that get ourselves into the market, learning to do business. But we were surprised, right? Even for an entry-level device that when we start building them, I mean, we have only 20-ish people. And then we get it done, we get the market. Wow, we get a lot of interest. That's the time we interview.
Yeah.
And also we get the first wave of like business growth.
Yeah.
Right. So then at that time, we are very determined that we have to put the investment in this 16 nanometer titanium, which is like totally unleashing the high performance together with low power. And so along that way, as a small company, it wasn't easy.
Yeah.
Because that was a very critical decisions. I mean, we could have said that, let's be safe, let's build something easy, cheaper, and go for the low-end market.
Yeah. Yeah.
We make a conscious decision and say, hey, let's skip the really low-end market, right? There are a lot of great company there, either FPGA or microcontroller company. Let's move upstream. And then we made that decision was very brave, because taking 16 nanometer investment with high-speed transceiver is not inexpensive.
Yeah.
And then, but very grateful, the team executed, and then within the 3 to 4 years time frame, we actually deliver how many products we have. There at least many, more than, I think 60% of the Orin codes, maybe 200 to 300, is titanium right now. So, and then we execute really well, and then it didn't blow the budget. And very exciting, I mean, as a company, we also managed to break even with the titanium. So that's a great journey. As I said, that's changed everything. On top of it, AI arising.
Yes.
And then we see, okay, should we double down, just like everyone to race against going towards the data center?
Yeah.
Then we made a decision, don't be too aggressive.
Okay.
Because we believe that somewhere right now in a mainstream FPGA market, they can have a big room for us to improve efficiency. Yeah. By saying efficiency means power performance area, as simple as that.
Yeah.
And then we focus building titanium around that, build enough interface, and we have a passion to also build a newer ecosystem. So make sure that our product, our technology can go to market much quicker. So that's why we are right now enjoying those decisions. We didn't go too low, we didn't go too high, but Edge AI is coming up, so we are perfect timing.
Well, yeah, that's basically what your summary of what you just said is, you've gone to the next generation of technology in the space of just a few years, and yet you still break even. So if you made the investment and you're breaking even.
Yeah, but it's a bit stressful over the last 3 years. Was it correct? Did we make the right decisions?
Yeah.
And I think it's totally right decision. And right now we are totally convinced that while we still have more titanium device coming up to allow the community for innovations to prosper, on the other hand, it's not a secret, we already work on next generation architecture, looking at more advanced processes. And the timing is right, because our first wave of penetration in the Edge AI market get tremendous feedback from our clients, our customers.
That's your first generation.
Oh yeah, that's one of the things that a lot of people asking that, what a secret sauce. Simple. We make our product straightforward, and at the same time, we make a decision fast, and we listen to the customers.
It's called being agile.
Exactly. So while we are selling a lot of titanium, we also getting feedback and how we improve the product, how we improve the service, and how we improve the software, right? So
in that growth, the first phase of growth and then the second phase of growth, what are the things you've learned as a CEO, as a human being? What are the things needed to do all of this? I know you said a lot of hard work and then making brave decisions. Do you feel like you learned a lot from that?
Absolutely.
Yeah.
It's just a real-time learning, because I mean, our goal is not try to take sweet time to like this 10 years grow slowly, or take large chunk of money to gamble on the market. And so we have to stand very firm in terms of what we think the positions of the technology. And just like what I said just now, I mean, you can go with like a week can we play safe? Or there will be a way to say that, guess what, we actually can do a much high-end market. So the name of the game right now is how to keep the team focused and then be able to have a trajectory that fitting into what we are good at.
Talking of trajectory, do you have a roadmap that you can share? Because obviously one of your ambitions has always been, you've been talking to people in New York quite a bit, but it's...
You can only say that much.
Yeah, but I mean, beyond that, I mean, is there something that roadmap that you think, okay, this is what we really want to do and our customers to know?
No, I mean, same as what we talked about last time.
Yeah.
I think it's very clear that the range of the device we build is right now focused on the edge AI, but also it will just eventually by 28 and onwards grow into infrastructure and data computing. It's not data center, heavy duty data center computing, but there's a lot of in outside data center, and there's a lot of compute we will need going back to compute offload. So all this will require in terms of the roadmap. And right now we're selling a lot of titanium, but I believe that just a preview, we should be able to have a next generations, something around 2028, introduced to the market, which we have to be a bit creative because that's where the area when we jump into, I cannot say exactly which process node we are going to.
Because you need to work on it still.
Yes, I think it'll be more visible how fast, I don't want to call aggressive.
Yeah.
I call it we are very determined that to keep moving.
Okay.
And then, but on the other hand, at that time, we are how to build device of a product family that can harness, still taking care of what I call the general market. That's the market that I think has been kind of like not being well served. And because FPGA is going to very specific. But on the other hand, because of the AI is going to grow, they're going to be non-stop. But the application is still changing. So we have to be very, very still continuously, cannot just sit back and enjoy the growth. We have to be like every week, every month, we're looking at what are the changes, what can we do. We have, by the way, being in FPGA, being programmable together with RISC-V and accelerations, we can actually change our product at not necessarily at the hardware level, right? We can change it in a package level, in a software level, as well as in the AI level as well. So there are many things that we have to adjust for the market. One thing I talk about, what I call system integration, especially like system in package. It's one of the most popular product we have.
Okay.
Yeah, and the reason going back to the whole market push is size is matter.
Yeah.
And then any FPGA company can do that, right? I mean, the difference is we have the smaller die. Okay. So what that means is you also can get in a stack package, but thermally, we don't burn out the chip. Okay. Yeah, so those are one of the fastest growing area. I can quote it, it's okay. It's over 33% of our revenue right now is system in package related, sir.
Interesting. You mentioned the market, you mentioned FPGA, but when within the times I go around, I talk to lots of people, they're building arrays. I think I see companies that, like opposite me, they're building processor arrays, that they're building software to enable you to configure that. What's the challenge for you as an FPGA provider in non-FPGA companies, or is it still like the whole FPGA market that's the key area that is?
I understand that. There's actually 2-3 questions there.
Yeah, it is. Yeah.
First of all, it's exciting that we are in AI enabling world, and seeing so many new innovations is always great.
Yeah.
Right. So I think I see the wave, the interest. That's what the momentum we need in the industry. The second part is the standard way to do things is like FPGA. We don't, at least Efinix believe, we don't need to always be the chip.
Yeah.
So what that means is we want to focus to build better FPGA rather than say monolithic on the same chip, putting in too many other stuff.
Yeah.
So it creates an opportunity for us as long as we have the right interface, high-speed sensor. I mean, we have cases that pretty easily we can be a very nice coprocessor
Yep.
for a custom ASIC, and also like in a bigger system, we have a system in which we do all the sensor aggregations and pass through a long link to a GPU processing.
Okay.
Right. So what that means is, as long as you have a full product line, different density, different choices, we can do many different things. And the key part going back is, doesn't matter if there's a new innovations. I think they would need to find a way to do the time to market while doing
Deployment.
a set of deployment, as well as they need to have FPGA-like capability to do real-time processing.
Yeah.
So we can always find a way to work with other people.
Yeah.
I would say 95% of the cases, whether it's sensor, memory, or USB devices, or GMSL control link, and we all can be part of it, of the ecosystem. As a matter of fact, I mean, the reality is there's a lot of different partnership right now. Efinix being the device titanium being sold not like a single chip, we've been sold as a standard references. So
okay, yeah. Well, Sammy? Yeah, it's always a pleasure talking to you. But in terms of your final message for the audience, what are the key things you want the EE Times audience to like take away from our conversation?
Well, I spend a lot of time talking about Efinix, like a business growth and so on, but nothing changed since I started the company. It's not, I just want to try running a startup. I truly believe what I saw proposed by Tony was a crazy disruptive idea. Tony, my co-founder partner, he created this technology. We are going to make some really good changes in the industry, and I encourage everyone to test drive, because it will give you a totally different experience in innovations. That's why I say business is business, but I think this technology can help enabling a lot more innovations than what we may think. Yeah.
Well, we've been needing innovation in the AI, the physical AI, the robotics market. So I think that's kind of
absolutely. I mean, this is one area that a lot of established big company start walking away, try to serve general community, because they are not like the biggest customers.
Yeah.
But on the other hand, I really love to get the message out. I mean, it's all proven. I mean, I should disclose a little bit how many units we ship. We ship over or more than 50-60 million units over time. So that's a lot of units. Is totally proven.
Okay.
And also ecosystem. We love, a lot of people love to develop their reference design, development their development kit. So it's totally open. Just come to Efinix.
Okay.
And it's just as I said, it's a new paradigm of FPGAs.
Well, Sammy Cheung, thank you very much.
Oh, thank you.
Thank you.